Hi, I'm AJ from STEMscopes. I'm one of the account managers here for math, and I want to share a lesson with you today on fractional parts of a whole. This is from our third grade curriculum. The name of the scope is Modeling Fractions, and this is the first Explore activity under that scope. To work along with me, you'll need to download and print a copy of our Parts of a Whole student journal sheet. And then I have already made my little cards here for the story that we're going to go through together as we explore some fractional parts of a whole together. So the only other thing you might want to get ready is some different sizes of scrap paper. I've cut out some pieces that I'm going to use to model some fractions. You could use anything you have around your house, but little scraps of paper work really well. So we'll use those in just a little bit. So let's get started. So the story we're going to go through together today is about a special dinner. And here's the very first card. At the entrance of the restaurant, there was a huge window that let in a lot of sunshine. One window stretched all the way from the floor to the ceiling, and it's divided into 8 equal window panes. Oh, I heard my first clue that there's a fraction involved. An employee is washing the window and has cleaned 5 of the window panes. So where's the fraction hiding in this piece of the story? Well, we know that a fraction is part of a whole, and it has to have equal parts. So where are the equal parts here? Well, it says that the window stretches from the floor to the ceiling and is divided into 8 equal window panes. Okay, so I'll let this strip of paper here represent my window. And what I need to do is divide it into how many equal pieces? The story told us 8. So I could do that by folding it pretty easily. Fold it again. 4 equal pieces, and I know that if I double 4, that should give me 8. Crease. Let's check our work here. Okay. Do you see 8 equal pieces? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So we have a good model here of our window. But that's not enough for a fraction. We now need to know the number of pieces that we're talking about. So where was that in the story? Let me see. Oh, an employee was washing the window and has cleaned 5 of the window panes. So I need to mark 5 of these window panes. I'll just do that by shading them. 1, 2, 3, 4, 5. That looks like a fraction. What fraction is that? Let's fill in the blanks here. Blank of blank window panes were washed. Well, we shaded in 5 to represent the window panes that were washed. So I know that that's 5 of how many total window panes? 1, 2, 3, 4, 5, 6, 7, 8. There were 8. We can turn that statement into a fraction. Let's write that in. The number of washed window panes was 5. And the total number of window panes is 8. And remember, we call this number here at the top, that's the numerator. It tells us the number of equal parts that we're talking about. And we have the denominator at the bottom, which tells us the number of total equal parts there are in the whole. The last thing I want to do is I want to draw my model in this blank space here. So I have it recorded. I'm going to draw it this way. Drawing fraction models is kind of difficult because you want to make sure that you have equal parts as best you can. It's okay if it's not perfect. So I made my paper model this way, but notice it doesn't matter how we turn it. It doesn't change the fraction. So I'll draw it this way on the sheet. And I need to shade in 5 of the 8 for 5/8. 5/8. All right, let's go to the next part of the story. The menu. The restaurant's menu is divided into 6 equal sections. 3 of those sections list dinner items, another section lists lunch options. The rest of the menu is dessert, my favorite, and drink options. So now we're going to model a menu. And in our menu, we're going to shade in the sections that list dinner items. So let's build a paper model of our menu. I'll use this green sheet. We have how many total equal parts do we need in our menu? Let's see if we can find that in the story. Do you see how many equal sections there are? Yeah, there's six equal sections. So I need to divide my model into 6 equal parts. I'll just do that by folding. You may prefer to draw this one because folding sixths is a little tricky because you can't start by folding it in half. So let's check. Do I have 6 equal parts? 1, 2, 3, 4, 5, 6. Are they all equal? Looks good. Those are sixths. I can already fill in my fraction, can't I? I know that the denominator must be 6 because there are 6 equal parts in the whole. Now, what is the part that we're talking about here? It's asking us to find the dinner items. So let's see, what does the story tell us about dinner items? 3 of those sections list dinner items. Oh, very tricky. We had a word instead of a number there. Okay, 3 of those sections list dinner items, so we should shade in 3 of our sections. I'm gonna draw a D for dinner on this model, just a different way. There we go. So let's check it. I have 1, 2, 3 of the sections marked for dinner. There are 1, 2, 3, 4, 5, 6 total sections. I can fill in my numerator. Awesome. That's 3 dinner sections. There they are. Let's see what else we need to finish here. Okay, blank of blank menu selections are listed are dinner items. That's easy to do. I already have my fractions. I know that 3 of the 6 menu sections are dinner. And the only thing left to do is to draw my model. I'll draw this one just like I had it on paper. Make sure yours has 6 equal pieces. Oops. I'll put D for dinner. All right. Looks good. Let's go to the next one. All right, this one is the caramel apple. I'm getting into dessert already. I love this. Okay, sitting across from your table, you see a mom, a dad, and 2 girls and a boy. The parents are sharing a huge caramel-covered apple that has been divided into 2 equal pieces. The mom eats 1 piece of the apple. Where's our fraction here? Caramel apple will be hard to model using something like this because apples really aren't that shape. So I'm going to use a circle because I think that's a better model for something like a caramel apple. So I have my whole. How many equal parts are there in the whole according to this part of the story? Let's see. It says the caramel apple has been divided into 2 equal pieces. So I can take my paper model for the caramel apple and I'll just fold it in half carefully. There we go, and you can see that I have 2 equal pieces. Perfect, that's a good model. All right, what is the part we're going to shade? Let's see, what's up here? We want to shade the piece that mom ate. Okay, let's go back to the story and see if we can find the piece that mom ate. Parents are sharing a caramel-covered apple. It has 2 equal pieces. The mom eats 1 piece of the apple. That's easy. So we have our 2 equal pieces. I'll shade in the piece that mom ate. Now let's convert that into a statement and a fraction. The mom ate blank of blank pieces of the caramel apple. Well, the story says she ate 1 piece. I shaded in 1 piece. I think that has to be 1. How many total pieces were there? This one's easy. There were 2. Let's transfer this statement, the mom ate 1 of 2 pieces of the caramel apple, into fractions. The numerator is the number at the top, tells us the number that we shaded in or the number that we're talking about of the equal pieces, and she ate 1. The new denominator is the total number of pieces. In this case, it was 2. 1, 2. We call that halves. So this would be 1 half. You've heard that before, right? 1 half. So mom ate half of the caramel apple. We need to record our model here in drawing form. I'm not a very good artist, but I'm going to try to draw an apple the best I can. There's an apple and a leaf. And I'm going to cut that apple right down the middle. And I'm going to shade in the one piece of the two total that mom ate. That's 1/2. And that matches our sentence as well as our fraction, half. Good, cool to know we can use circles, we can use rectangles, we're doing well. Let's try another one. Oh, the napkin, okay. So the cloth napkin that they give you is folded into 3 equal parts. You notice that 2 of those parts are beautifully embroidered, it's a new word, with colorful flower designs. So I'll go back to a rectangle for this one because I think napkins are usually rectangles or squares. And where is the fraction we need to create in this part of the story? How many equal parts were there? Well, it does say that the napkin was folded into 3 equal parts. I'll show you how to do that. If you can't start by folding in half because 3 is an odd number. If you fold it in half, you're going to always have even, right? So to make 3s evenly, you can do a little, I call it the burrito fold. So you fold over a little bit. Try to get it on the screen there for you. And then a little bit more, and then make sure that it's equal, and then flatten it. You learned the burrito fold. Okay, so we have 3 equal pieces. I think so. 1, 2, 3. Looks good. Now, where's the rest of our fraction? We notice that 2 of those parts are beautifully embroidered with a colorful flower design. Even kind of gives us a little hint in the picture there of what that should look like. So I'll draw my flowers. Yours will be way better than mine, probably. I'm not a very good artist. That's okay. These are just models. There we go. And let's see what we need to record here. So I have a really good model. We shade the pieces that are embroidered. I drew, instead of shading, I just drew the actual flowers on those pieces, so that helps. Complete the statement, blank of blank parts of the napkin are embroidered. Well, that's easy. How many parts are embroidered? 2. And how many total parts were there? 3. We did that burrito fold. We can convert that to a fraction. There are 2 embroidered pieces, and there are 3 total equal parts to this napkin. Do you know how to read this fraction? When something's divided into 3 equal parts, we call those thirds. And so this would be 2 thirds. 2 thirds of the napkin are embroidered with flowers. I'll let you draw that now in the box. There we go. 2 thirds. I think it's interesting in this fraction that the pieces that we shade are not touching, and that's okay. That's still 2 out of 3 total. If we would have shaded the top 2 pieces and left the bottom one unshaded, still would be 2 thirds. So it doesn't matter which ones you shade, as long as there are 2 shaded and 3 total, and they're all equal. Okay, we're moving through this dinner. Card 5 is the bread. If you've never been to a fancy dinner before, usually they bring you some bread after you order your meal so you have something to snack on while they cook your food. Fancy food takes a long time. The waiter brings a small loaf of bread. You cut it into 4 equal parts. You and your friend each take a piece. I'll use a nice long strip of paper here to represent a loaf of bread. And we're getting the hang of this now. Let's see, where is the fraction in this part of our story? We cut it into 4 equal parts. Okay, so there we go. Let me fold it. Okay, make good equal parts here. I know that if I fold it in half once, I get 2. If I fold 2 in half again, it's 4. So there's my model for loaf of bread. And I'll just trace those creases so that you can see them. Do we have 4 equal parts? We sure do. 1, 2, 3, 4. Perfect. And what is the numerator? What do we need to shade in? It says you and your friend each take a piece. Okay. So this is the part that I take. There's the part that my friend takes. All right, let's record this one. Here it's getting a little different. So for card number 5 about the bread, we want to know how much of the bread loaf is left. Oh, that's interesting. All along we have been talking about the numerator being the part that we've shaded, but we could also use the numerator to describe the part that's unshaded. It just depends on what the instructions say. So here we want to know how much of the bread is left. And we have 2 parts that is left out of the total 4. So let me draw my model here, and I'll draw my model a little bit more like a loaf of bread. Close to equal, looks good. And this is one part. There's another part that we took. But remember here we want to look at the loaf that's left. And so that would actually be this section here that's left. So how many pieces are left? Well, there are 2 pieces of 4 pieces total left. Now we have to write it in word form. We've been saying this out loud all along, but let's write it. And you have on your sheet here up at the top, you have some words to help us. I'll just say these for you: half, third, fourth, sixth, eighth. This is interesting. Which one of those words could you use? Well, I would normally say 2/4 of the bread is left. So we could write in 2/4. I know that fourth is the one that has 4 equal pieces. It's easy to remember because 4 is in the name fourth. There's something else we could use to describe this one though. Think about that for a second. We could maybe look at our paper model, it would help us too. What if we shaded it like this? What do you notice about this piece and this piece? It's interesting. It's half, isn't it? So we could also describe that as half if we wanted to. The fraction we're dealing with here is 2/4, and we would write the 2 at the top because it's the numerator, and 4 at the bottom because it's the denominator. 2 out of total 4. Okay, good deal. That was a little bit tricky. No big deal. We'll move on to number 6 here, the butter. I can't have bread without butter. All right, along with the bread, the waiter brings a stick of butter. It has been cut into 8 equal parts. You take 1 piece for your bread. All right, for butter, how many equal parts are we working with? Keep it on screen there. I'll use green for my butter. You got it, 8 equal parts. I folded my paper into fourths. And I know that if I fold fourths in half again, that doubles it, which should make 8 because 4 plus 4 is 8. 4 times 2. Looks good. Let's make sure we have 8 equal pieces. Check it with me. 1, 2, 3, 4, 5, 6, 7, 8. Very good. All right. How much butter did you take? Well, what does the story tell us here? It's been cut into 8 equal parts. You take 1 piece for your bread. So let me shade in 1 piece. And that would be 1 piece that I took out of the 8 total. We can draw our model. One, 2, 3, 4, 5, 6, 7, 8. You know what I'm noticing is that when there are more pieces, the pieces get smaller. It's good, you don't want very much butter. And I should shade in 1 of these. Does it matter which one I shade? It doesn't really, because 1/8 is 1/8 no matter which piece you shade. You might shade this one or this one, but I chose that one. My paper model, I shaded the corner one. Doesn't matter, they both represent 1 piece shaded out of 8 total, so that's 1/8. Let's write it into a statement. I took 1 of the 8 pieces of butter. Now we have to write it. We've been saying it. Let's see, look up here at our word bank. Half, third, fourth, sixth, eighth. Well, it's gotta be this one because it sounds like 8. Oops, you can't see that. Eighth. So I took 1/8. And we can write it into a fraction. You're a pro at this by now. The numerator is the number that we took. The denominator is the total number of pieces, 1/8. Okay, we're getting close. 2 more to go. Let's go to card number 7. Oh, the main course, the steak. All right. Of course, you ordered the steak because it's delicious. And it finally arrives sizzling. It is so big, you decide to cut it into 6 equal pieces to share with the others at the table. Thank you. 3 of your friends take a piece. All right. Let's see, we've got another rectangle here for the steak. And we need to divide it into equal parts. The story tells us there are 6 equal pieces. So let's do that. Right. There we go. And I will trace those so that you can see where my folds are and check my work here. Are there 6 equal parts? 1, 2, 3, 4, 5, 6. Looks good. Now, since this one we're actually cutting it and sharing it, I'm going to go ahead and actually use some scissors and cut my model. You could do this too if you're using paper and you have scissors. Be careful. So we have 6 equal pieces. We're going to share with others at the table. 3 of our friends each take a piece. We want to know how much steak did your friends take. So let me cut some pieces here so you can see. There's 1, 2, 3. So even though I've cut the pieces out, I can still show my model with a hole. There were still 6 total pieces of steak, but I cut out 3 and my friends took these 3 away. Let's draw that model. We can draw it just like we cut it if we want. There are 3 that are still there on the steak, and then here are the 3 that I took away. I'll shade those in to show that those are the ones we're talking about. Now let's translate this into our statement. My friends ate blank of blank pieces of steak. Well, these are the ones that they ate. So they ate 3 of the 6 pieces of steak. My friends ate 3. And we've lost our word bank, but I'll just tell you, it's 6. 6th is the word that we're looking for. And that's easy too, because 6th sounds like 6. It has the 6 at the beginning of it. Can you translate that one into a fraction? We need a numerator and a denominator. I'll do the denominator first this time. Denominator tells us how many total pieces. There are 1, 2, 3, 4, 5, 6. My model helps me with that, good. And the numerator is how many my friends took in this case, which is 3. 3/6. This reminds me of the caramel apple. Let me find that one. What do you notice about these 2 models? They're both halves. That's interesting. A little foreshadowing maybe. Okay. Last one, the cake. I've been waiting for dessert. You see that the dessert menu includes your favorite orange chocolate cake. As much as you would like to devour the whole thing yourself, you decide to be generous and share with your 2 best friends. The cake is cut into 8 equal pieces, and each one of you eats a slice. Well, remember, the more pieces, more equal pieces we cut it into, the smaller those pieces are. So I'm glad you're willing to share. These are going to be some small pieces. Let's do some folding to represent our cuts. I'm using a circle because I think cakes are usually circle. Maybe you've seen a rectangular one. It doesn't matter what shape we use as long as it's equal parts. So we're looking for how many equal pieces? 8. Oh yeah, they're going to be tiny. So there's one fold makes 2 equal pieces. If I do another fold, that's going to be 4 equal pieces. And then if I double 4, I know that I get 8. Folding a circle is tricky. You want to make sure you. There you go. 8 equal pieces. Let's make sure that they're all there. And I'll just trace the lines here for you so you can see. One, 2, 3, 4, 5, 6, 7, 8. Perfect. We can even draw our model right now. One, 2, 3, 4, 5, 6, 7, 8. Now we need to do some shading. Where's the story? Tell us we need to shade. So we have 8 equal pieces of this cake. And the cut is, you're being generous and sharing with your 2 best friends. So the cake is cut into 8 equal pieces and we all eat 1 slice. So here's a slice for you. And who else do we need to give slices to? Well, you're with your 2 best friends. So here's 1 for one friend and 1 for another friend. This can be tricky because sometimes we forget to count ourselves. If we're reading it in a story like this, it says, we decide to be generous and share with your 2 best friends, and everybody gets a slice. So that's not 2 people eating cake, that's 3 people, because you have to count yourself, me and my 2 friends as 3 people. And so here are the 3 pieces of cake that we've shaded in. I could cut these, but I'm not going to do it this time. I'll just update my model here in my drawing. 1, 2, 3. I decided to shade pieces that don't touch, and that's okay. Those are the pieces that we took. Probably you would take the 3 biggest pieces. All right, let's fill in the statement. We ate 3 of 8 pieces of the cake. We ate 3, and when you divide something into 8 equal parts, it's called eighths. Eighths, it's hard to say, E-I-G-H-T-S. And that's another one that's easy to hear because it has the word 8 in it. So 8 equal pieces is eighths. And we know how to write fractions now. We're really good at that. It's going to be 3 on the top, 8 on the bottom, because we ate 3 out of 8 total pieces. We're good to go. All right, that was fun. Okay, so we went through a whole dinner scenario. We recorded all of these different fractions. Just look at how different each of our models are from one another. Lots of different ways to model fractions. You've practiced writing it in word form and statement form and fractional form. We have pictorial representations. Hopefully you worked along and even made some of the physical models with me by folding some paper. Fractional parts of a whole. We like to end all of our hands-on activities with a really good math chat. It's going to be hard to do because I'm not there with you right now, but I do have a couple questions that I want to share with you just to make sure we recap and review. So what does the top and the bottom number on a fraction tell us? You know this already because we've done it several times together today. The top number of the fraction is called the numerator, and it tells us, that's right, how many items are shaded in or what we're talking about. Remember that we did have one example today where one of the examples was the items that were not shaded in or the parts that were unshaded. And that's okay too. You just have to make sure you're reading or listening carefully to what the instructions are so that you know what you're talking about for that numerator. And the bottom is the denominator, which is the total parts, total equal parts in the whole. Good deal. How are fractions helpful to you? Well, we talked about several different cases in our story of going to dinner. My favorite one was the last one, the cake. Fractions are very helpful when you have friends and you want to share one thing with many people, you're able to cut it into equal parts. And especially when we're doing cake, we want to make sure those pieces are equal as possible when we're sharing it, right? So fractions help us share things with others evenly. That's important. Last question, what are some other situations in which you might use a fraction? You could look around the room right now, wherever you're watching this video, and probably see fractions all over the place if you think about it. Remember, the very first part of our story today was when we walked into our imaginary restaurant, and the first thing we noticed was this window, and it was divided into window panes. There are 8 total window panes, and somebody has cleaned a certain number of those. So even something as simple as a window can represent a fraction. So look around the room where you are right now and see if you can find a fraction, something that's whole and divided into fairly equal parts. Fractions are all around us. Cool. I enjoyed sharing this lesson with you today. I really appreciate you